Good morning to all. I guess that we can start now. The others will join us later. So thanks for coming this morning. Uh, Today we'll have just 1 hour of theoretical introduction. I will give you this one lecture, and it will be followed by 3 hours or more interesting practical part of this course, where you will go through some examples of AI applications in business, and you will be working with my young colleague, and she will present you different examples in Python. So just after 1 hour of my lecturing, or 45 minutes, at 11 you will continue this course, but with her. So we will continue where we stopped yesterday, meaning that we will go through a few more examples of how artificial intelligence is already implemented in many areas of business, and what are the benefits of the application of these systems. This part will discuss more about the application of artificial intelligence in customer service. And generally, artificial intelligence brings a lot of benefits to companies which has different customers or clients, and it can enhance or improve the overall customer experience and satisfaction, which is very important if you want to keep your customers with you. Nowadays, customers they are expecting a almost perfect service, and they want they are ready to share their experiences. So compared to some previous times, now if you have a good or bad service, customers have the influence or the possibility to share their satisfaction with you using, for example, social media or social networks. So it's very important for the companies to have satisfied companies, because if they are not satisfied, then many others could hear about that. So therefore, all companies must try to improve their contacts, their communication with the customers, and to offer them real good services. And it could go, it goes in different directions. The service could be faster, so they could get the answers quickly, or the service quickly, or the products more faster than previous. Also, some services or some part of the communication could be automatized. And also, very important aspect of the application of AI in customer service is the personalization. So we will discuss all of these possibilities in more details in the next few minutes. And of course, customer service must be very reliable for the customers. One of the important advantage of the application of artificial intelligence is that it lacks emotional bias and minimize errors, which usually are generated by humans. So at the moment, artificial intelligence systems don't have emotions, and they are very rarely they make errors or mistakes compared to humans. So that is why the services they could provide generally would be better than human prepared services. Another big advantage is that these systems are actually software systems, and that they are available 24 hours per day, 7 days a week. So customers can interact with the company or with the service center whenever they want and from every location where they are at the moment. And the most important example of these are chatbots, because they can give you let's say precise response without any human interference. Generally, many companies now are developing chatbots, and they have many advantages. One of them is that they can handle more customers at a time compared to, for example, human support. People which are working in, for example, call centers, they can service one customer at a time. They can talk or discuss with just one customer at a time, and these call centers usually don't work during the night. And compared to them, chatbots actually are working day and night, and they also can give answers to many customers at the same time. So they are much more effective than human support. So sometimes, in case of very specific questions, we need at the moment we need the humans to get involved. But generally, most of the questions are regular questions which many customers are asking. So chatbots could easily solve, let's say, 80% of the problems that customers are dealing with. So this option that we have the possibility that provide the customer assistance at any time and at any location significantly improves the customer experience, and actually there is no longer need for them to wait in a queue or to make frequent calls, because you know how it works in old system. You call some company by phone and they tell you there are 4 people in front of you, please wait, please be patient, and you are waiting and waiting for 1 hour to get into contact with a human operated. And of course you are unsatisfied because you have to wait to get this service or to ask a simple question. Here AI can provide the straightforward communication and quick communication with many customers at the same time. So also interesting is that new systems developed can also implement audio or facial recognition. So in this manner, they can analyze actually the emotional status of the customer who is at the moment calling. So if he is calling you asking some question and you see that, for example, he is confused, then AI will generate quite simple and slow answer to this kind of customer. If your, let's say, emotion detector detects that the customer is very angry, then you can apply artificial intelligence would apply a different approach to try to calm him down and to explain him in details what is the problem and how to solve. So also this emotion detection is included in some of the chatbots which are developing now. So these characteristics of artificial intelligence, that it can adapt to specific circumstances and specific demands, is very important in order to provide very good customer service to our consumers. Another important issue with artificial intelligence, that it can learn during the operations, so it gets better and better. It learns from every example, it adapts, and for the next session, it could provide even better answers for the customers. Another option is its prediction capabilities. artificial intelligence can even predict what the customers might ask or what might be their future problems. So even this could be very interesting because they can provide faster and personalized service to anyone. And of course, after that, customers would be more satisfied with your company. As I said previously, customers need swift assistance, so they don't want lengthy wait times because they are then unsatisfied. So it means that this capacity of artificial intelligence to deliver faster and efficient services is very important in order to keep your customers satisfied, because, as previously said, there is no need for sequential one-to-one response to customers, no need for long queues. AI may operate really in real time. Another advantage, of course, is automation, because some tasks which are repeating constantly, customers can perform very quickly using AI solution. And finally, we discuss hyper-personalization. We will mention this term several times today, but AI is based on a collection of a lot of data that may include some personal data of the customer, of course, if it is allowed, and also some previous search history, previous purchases, previous behavior of the customer on the platform. So based on all this information, systems are ready to recommend products or services or some content or information. And this also could lead to the better fulfillment of the customer needs and to customer satisfaction, because he will get something that he would say, oh, yeah, I really might need this. This is a good suggestion, which is provided by the system. So we will discuss these recommendation systems in more details in just a few minutes. We already passed this because the technology provides us the possibility to, let's say, give them personalized experience. Here are some of the example of the customer services, but we will discuss some of them. First, let's say one of the most important ones is are recommendation engines. Recommendations engines are applied in many services that you all are already using. The idea is that companies, particularly companies in e-commerce business, no matter if they are offering you some products or services or content, we will see all different examples. The idea is to sell more. So if you came to one website and you want to buy some product, the idea with recommendation engines is to provide you some more ideas. So if you want to buy one, for example, product, we are offering maybe to buy this another one, which is complementary with the previous one, or which is maybe much better than the one that you are looking at. There are different strategies, cross-sale, up-sale. We will not talk, it's more for e-commerce course, but the idea of recommendation engines is to provide you a good recommendation and to try to persuade you to buy more, to spend more on the same platform, to buy more products or to spend more time on platforms such as YouTube or Netflix. And we will see how these systems could work. It's important to notice here that artificial intelligence here is mostly used for personalization. So to find the best solution for every person who is for every customer. And here is one of the examples. If you visit Amazon and look for some book, he will always offer you some other products related to the book that you are looking. And then you have numerous examples. If you visit any other web shop, a good one, you will get below the product that you are looking at, you will get the list. The other consumers also bought this product, or if you are looking some video on YouTube, you will get the recommendation of some other videos that you might be interested in, or the same goes for Netflix, for Spotify. The general idea is to keep you busy, to keep you more on the same platform and to keep you satisfied, of course. Um, how does this work? Of course, these engines analyze user data and try to predict preferences, to recommend the product that is in line with something that you like. And as I already explained, all systems that many of you are already using, such as Netflix, Amazon, even social networks like Facebook or LinkedIn, use these kind of engines to recommend you new friends, new contacts based on some your history on the platform. For example, how movie recommendation system works. The platform knows your age, knows your previous preferences, knows how you interact with some previous movies. And for example, if you watched many science fiction movies and you give them high rates, then the system will consider that you are the fan of this kind of movies, and of course it will offer you more and more movies of this profile, or from the same actor, or from the same area, etc. So it is not implemented only in the online platforms. We can meet the same systems within the offline world. So, for example, if you use we all have these loyalty applications in supermarkets, for example. You get some kind of credits if you are buying using these loyalty cards or loyalty applications. And you could notice the trick that when you are at the checkout register, they scan your application in the supermarket, so they know what you bought yesterday, for example, and you can get some kind of coupons for the future purchases. So they know that you like some product, so they're saying only for you, here is a coupon for the next time you will get 10% discount or 20% discount. So the idea is to keep you coming in the same shop, but based on the personalized discounts, not general ones, but they just know what you are buying and what you like to buy in this shop, and they are trying to offer discounts just for you, for the products that you are interested in. The same goes for the music and bookstores, when again they are making some kind of profile of you, and based on your previous purchases, then can predict can suggest what other book or music you should buy or listen. The same goes for investment companies. I don't know if we'll manage, but you will have teaching materials available with more details on the application of artificial intelligence in finance. But investment companies are also developing artificial intelligence solutions which could recommend you which stocks you should buy. Again, based on your previous interests and your previous characteristics. Do you want to risk more and to gain more, or you want some safe investments and some other, your age, your location? These systems could provide you recommendations what at the moment are the best stocks that you could buy. The same goes, of course, for companies that provide you some video materials like Netflix or YouTube as a platform for video materials. The same goes, of course, for the social media or social networks, where again Facebook or Instagram or any other social network recommends you additional connections based on your existing networks. So based on your friends or some contacts in your mobile phone or some recent interaction on the platform, you get new recommendations to whom you should connect and share your interests. There are two major two major categories how these recommender systems actually work. And these are content-based recommendations and collaborative-based recommendations. And content-based recommendations, actually, this approach works based on the idea that we should explore what the users prefer in the previous period. So we analyzed these systems actually analyzed the previous purchases on the previous behavior of the consumer or the customer, and that is the way how they are trying by comparing the same features. They try to recommend the item or the product that it is likely that user will be satisfied with. So, for example, if you are buying, you are always watching one kind of movies, then you are, let's say, the consumer that likes this kind of movies, and then the system will recommend you the same kind of movies which you haven't previously seen, but it's from the same category or from the same actor or something else. The same goes for all other services. For example, when the system wants to suggest you to recommend you some hotel based on your previous bookings. For example, you always book hotel with 3 or 4 stars, maybe close to the center. Maybe it should have a swimming pool. Maybe it should be pet friendly. So there are some features, some characteristics of the product, of the hotel, for example, that you prefer. So the system knows this and then immediately recommends to you the hotels which are in line with your preferences, with your previous bookings of the hotel on the same platform. And in this system, it is very important that the items could be, as I told you, products or services or content, have a lot of features. So we can compare different items based on these features. And also it is possible to include likes and dislikes. So if the system knows that you don't like some kind of product, then it should not be offered at any time, because it could cause some kind of dissatisfaction of you as a customer. The same goes for the systems that with the news, for example. You now have the website of the applications who actually, based on your interests, prepare you the list of news that are let's say tailored for you. based on your previous interaction with the system. And they are not presenting you some news that they know that you don't like to hear. The other approach is called collaborative recommendation, and it is based on something called collaborative filtering or social filtering. Here, it is not that what you were buying before and then predicting just on your previous behavior. Here, the system works in the way that it predicts your rating for the movie, identifying the other users who share the same taste. It means that actually it's a group analysis. For example, there are you like to go to watch, for example, science fiction movies, and there are others on the platform who also like to watch science fiction movies, and you are similar to this group. And for example, from this group, they know the system identifies that they also like some kind of comedy. They all rated this particular comedy very well. So based on this group similarity, because you belong to the group which has similar taste, the system will recommend you this comedy, hoping that you also will agree with the others and rated well. So you will not get science fiction movie, or you can get some other suggestion based on the ratings of the others who have similar taste to you. So here the system works by aggregating the ratings of other users with similar patterns to yours, and they predict the rating that you would give. So if this rating is high, then it would be recommended to you. It could depend on many features. It could be, genre, specific director, specific actor, but the important point here is that this kind of filtering, social or collaborative filtering, actually identifies some characteristics that are shared with a group of users. So if you are similar to this group, then it's some kind of inter-user comparison. So if you are similar to this group, what they like, it is, let's say, suggested that probably you will like. And it is similar to something called word of mouth, something that if your friends like something, well, you are a friend with them, you share similar interests, probably you will like it too. And Amazon is one of the first companies which implemented this kind of filtering, but today many other big companies like Amazon, Netflix, and Spotify use the same approach. Collaborative filtering has two branches, two different approaches: user-based and item-based. In user-based, as we discussed, the focus is on individual users. So we analyze information about all individuals, and then we have this assumption that similar users share the similar interests, and the prediction is made by the assumption that if they all share the similar taste, then if a group likes something, then probably this one individual will also like the same item. The another approach is item-based approach, and here we don't. It doesn't involve with the individual users. Here we look at the relationships between pairs of items. It means that based on previous purchases of many people, you have some kind of matrix. If somebody bought one item, what is the probability that he bought some other item? So, and that is the basis of the recommendation. So if people usually buy, I don't know, beer, they usually buy also chips. So if you are buying beer in some online shops, they will say, okay, you might be interested in buying chips too for this beer, because in this matrix it is noticed that these two items all usually goes together in the shopping cart. So these techniques are very useful, very often used, but there are also some challenges still unsolved. Sometimes there is insufficient data. You don't have enough data to make a good prediction, and it could be a problem because, as I told you previously, most of the artificial intelligence systems are based on a lot of data. They need a lot of data for training. Sometimes we have the opposite situation. We have too much data, so the system could not work in real time because processing time is high and you cannot get the uh, estimation in a short period. There are problems with the false reviews. For example, if you are looking for the hotel, sometimes you have false reviews. Some individuals can write positive reviews for their own products or negative reviews for competitors. So sometimes the data which you are using for training are actually not good. They have some bias which we discussed 2 days ago, so it could influence the final results. And also lack of diversity. Sometimes you don't have enough products, so the system keeps recommending you the same items. There are different machine learning and artificial intelligence which can be used in this system. Some of them are regression, decision trees, k-nearest neighborhood, support vector machines, neural networks, and of course, naive Bayes. Customer churn is another example. Customer churn, I don't know if you know what this means, but customer churn is actually when the customers are leaving the company, and it could be very dangerous for the company if too many customers are leaving at the same time. And here we use the artificial intelligence algorithms to prevent customers to leave. So the idea is to analyze a lot of data to make some kind of customer profile, to make segmentation, to group these customers in different groups, and to identify features which could predict if the customer will leave or not, and then to prevent this, to make some marketing action to keep him within the company. Because if the customer leaves, it brings us a lot of problems because the company is losing money because he no longer pays for some service to the company, and also the expenses of attracting new customers are much higher than to keep a present customer within the company. And this is one of the frequent problems everywhere because many companies, if you are a client of some, let's say, mobile phone company, you know that they are always offering better conditions, they have better offers for new users, and old users then are usually not satisfied with this, and many of them could leave. So the general idea here is to try to prevent your customers to leave and to retain them within the business. And it is not only for the current customer, it's also for the new customer, and to try to reactivate inactive ones. And you will read more about this. The idea is generally to reduce the losses of sales and the losses to reduce the expenses of acquiring new um, new customers which the company needs. There are many different techniques which are used. Some of them are artificial neural networks, decision tree algorithms, support vector machines, naive Bayes classifiers, and the others. So it is, in this case, it is important to have a lot of data about your customers and to identify these triggers, to identify the features which could help us to know what customers are thinking about leaving the company. It could be, I don't know, maybe they have many complaints. If they have 3 complaints in the last week, they will probably leave. Or if they are not contacting you, maybe they are thinking about leaving. Or any of these signals could be a good signal to contact him and to try to keep him within the company. Social media analytics, social media is very important business model today. A lot of money are invested and generated by different social media or social networks, Facebook, Instagram, TikTok, Twitter or X, and a lot of AI algorithms are developed in this manner. The idea generally is to keep the customers as long as possible on the same network. And you know that many of clients of us are spending hours and hours on social networks. Theoretically, they are all free, but actually, your access to these networks is paid by your data and by your time. You are looking at some ads at this network, and that is how you are actually paying your access to these networks. They use many different kinds of data analysis and AI algorithms. One of them, of course, is image recognition. So all of us post a lot of images on Instagram or Facebook, and these companies have algorithms to analyze these images and even to analyze the brands of the clothes that you are wearing, and that then later can be used in marketing. So if they identify which kind of brand you are using, then you probably in some future time could get an ad related to this brand or some similar brand. Or if they notice that you are visiting some interesting places or you are traveling a lot, then they will try to send you more advertisements or ads related to travel companies or to some trips. So another issue, another application are chatbots, which are used these chatbots are getting better and better, and very soon we will have almost human-like communication with these chatbots. It will not be written communication; it will be oral spoken communication, and you will ask directly and get the answer directly by these chatbots. Some of the major examples are Facebook and Instagram, but here I just want to stress that these data also could be misused. And most of the customers are not aware how many information or data they share with social networks. And there were some serious researches related to how they could be used. And for example, if you, sorry, check if we can get this. No. Okay. The idea is that there was one big research showing that, for example, it's famous ocean model from psychology. You can search on the web if you are interested. But if system knows your 300 clicks, only three, there is with 70, with the 150, with 150 clicks, the system would know you better than your friends, and with 300 clicks, the system would know you better than your sorry. That you're supposed that your husband or wife, and with more than 300 clicks, for example, on frame, more likes, not clicks, but more something that you liked, they could know you better than even you know about yourself. So and this can be used for manipulation. And I don't know if you heard, for the company Cambridge Analytica, there was a big scandal some how it is 8 years ago, first when the Trump win the first U.S. presidency. This Cambridge Analytica is British company. Was connected to Facebook, and they collected data on Facebook with some kind of psychological test, so they could profile the users, and this data was used to create. Ads, political ads, for these elections. And here you will see that generally Cambridge Analytica wanted to persuade votes by showing them advertisements that were tailored exactly to what would resonate with their personalities. So by this test, they discussed the personalities of each person, and they present to each person some kind of personalized ad which had the most influence of this person. So it was not the same ad for the old consumers. For example, it was different ad for male, different for female consumers, and this had significant influence. It is one of the conclusions that this could influence the elections in the United States when Trump won his first presidency. And the company also influenced the Brexit referendum when Britain took off from European Union. So after this scandal, this company was closed. But it is important to know that the companies knows a lot about you just by analyzing what you like or what you don't like on the web. Instagram also provide you a lot of opportunities to by analyzing the data there to offer specific ads to by the companies that could influence your businesses. Customer loyalty programs, again, by tracking what you are buying, the companies can provide you some reward cards or some discounts. And there are many examples in finance, but unfortunately, we don't have time. You will have these examples in teaching materials, which will be shared by the organizers for you. This presentation is based on this teaching material, which will be available for you. And there are a lot of examples in other areas. We, of course, couldn't cover all in these only 3 hours. In finance, just short, let's say in 1 minute or two, many companies, banks, brokerage houses, and insurance companies investing a lot in technology, a lot of in AI solutions, because they have a lot of data about their customers. So they are, for example, if the bank want to give some loan to some consumer, now they use advanced systems which can determine the creditworthiness of each customer consumer. How risky is to give to some man the money. Previously, it was up to humans. They had some methods, but now the advanced systems analyze much more data, and they have much more precise risk assessment of any financial decision on any financial act. So either in processing the loan applications of the users or investing in stock markets. Now you have a great deal of everything going on stock markets today is actually powered by artificial intelligence agents, which actually have are trained to trade on the stock market. So by real-time analysis of all data, they can in a split of second decide to sell some stocks or to buy some stocks. So it is safe to say that current stock exchange markets in many countries are actually run by artificial intelligence, and it will go more in this direction in the years to come. So I'm sorry that the time has gone, so I don't want to take more of your time. You will have all this in the teaching material. You will have now a short break, and at 11, my assistant will continue working with you on the examples in Python. If you have any questions, because we don't have now time, I would like to give you some break. Please contact me by email, and I will be glad to answer to you all your mails and questions. If you would like to have slides, no problem. Slides are based on presentation, but I will send the presentation to Sandy, and Sandy, maybe you could share the presentation together with the teaching materials that we are providing for this course. Is it okay? I guess it will be. So thank you once again for to be with us on this course, and have a nice day.
Thank you. You too.
Hello, can you hear me? Just let me know if you can. Or don't. Can you hear me?
Yes.
Oh,
Yes.
thank you, thank you. I'm 1 minute early, but I guess it's okay. So, I'm Liliana. I'm an assistant at the Faculty of Economy in Kragujevac, and today I will show you some practical implementation in Python of some data sets. So I guess we can start now. Just let me share my screen. I'm now sharing. Can you see the screen?
Yes.
Okay, thank you. So, as I said, today's topic is practical implementation of some economy data set. I will start by introducing the marketing campaign data set. The marketing campaign data set is originally from Kaggle, so you can get it on Kaggle, download it here. I don't know if you're doing this with me or don't, but I guess I'm doing it all alone, just showing you, and then you can try it. So if you want to maybe write some code or something, you can download it on Kaggle. And when you get my file, it is linked here. So that's the link for marketing campaign data set. Or if you just type marketing campaign on Kaggle, you will get this data here. The data is originally in Excel files, so when you download it, you will see all this data, huge amount of data, and all these columns. We have columns like ID, birth year, education, and I will tell you everything about it later. So the marketing campaign data set, the goal of this data set and analysis is to use this data set and understand customer behavior and preferences to optimize some marketing strategies and improve their return on investment. Also, we aim to identify factors that are influencing customer responses and develop predictive models for campaign outcomes. About this data set. This data set contains.
Sorry, just a moment, please. Are you really sure the headset, because the voice quality is very wrong because of the headset? Sorry.
Sorry.
Thank you very much.
Can you hear me now?
Yeah, it's better. Thank you very much.
Okay, thank you for telling me. Yeah. So now it's okay, yeah?
Okay. Yes, thank you very much. Thank you.
So as you saw previously, we have some columns, and that's our data. First, we have columns accepted campaign 1 to accepted campaign 5, and that are binary indicators for whether a customer accepted the offer or don't. So 1 is for yes, 0 is for no. That's first 5 columns. Then we have response, that's our target variable, and it is also binary indicator for whether the customer accepted the offer in the latest campaign or don't. 1 is for yes, 0 is for no. Then we have complaint. It indicates if the customer has made a complaint within the last 2 years. 1 is for yes, 0 is for no. DT customer is actually date when the customer first registered with the company. Education is the highest level of education the customer has achieved. Martial is the customer's martial status. If they're alone, if they have wife, husband, etc. Kid home is the number of children under 12 in the customer's household. Teen home is the number of teenagers. Income is annual household income of the customer. Then we have M&T fish products, meat, fruits, wheat, wines, gold products, and that are all spendings on fish products, meats products, fruits, sweets, wine products. And the last one is for gold products. Then we have non-deals purchases. It is the number of purchases made with a discount. Then non-catalog purchases, number of purchases made using a catalog, number of purchases made directly in stores are non-store purchases, number of purchases made through the company's website is non-web purchases, and then the number of web visits monthly, and the last one is recency, number of days since the last purchase. And all this data are here. So you can see that for birth year, we have a year of birth. For education, we have if they're they graduated, if they're masters, PhD, etc. Then for marital status, single, together, married, etc. You will see all this data in the next lines of code. The first step for practical implementation is always importing libraries. So here we used all these libraries. If you want to just use my code, you will run it in Visual Studio Code on the left, and then we will have all them loaded. In this lesson, we use pandas for data manipulation and analysis, and we use pseudo PD for pandas library. For numerical operations, we used NumPy and their alias NP. From matplotlib.pyplot, we used all functions for data visualization, and we used PLT to have all these functionalities. Then we use Seaborn for statistical data visualization, CPy.stats for statistical functions, datetime, a library from which we imported datetime as DT. DT is pseudo for datetime, so we can type datetime, but we prefer to have some shorter name. So we use DT, and it is, as it says, for working with dates and times. From intertools, we imported combinations as comp, and that is for generating combinations of elements. From sklearn model selection, we use train test split to split our data, and grid search CV to cross-validate data and to tune our hyperparameters, but you will see it in the next lines. From sklearn pre-processing, we use standard scaler for pre-processing our data. And from metrics, we use confusion matrix, accuracy score, classification report, and that is all for some evaluation of our model. From sklearn ensemble, we use random forest and AdaBoost classifier, and that are a classifier used in our research. Then from linear model, we use logistic regression. From SME, we used a support vector, SMM, we use support vector classifier. And the last one is neural networks, and we use NLP classifier. That are all our models used in this lesson. After we imported all the libraries, we now have all the necessary functionalities, and we have to import our data. If you have your data in the same folder as this marketing campaign dataset final file, I have it in the same folder. So, okay, here I have the Jupyter source file. All the code is here, and I have Excel file from Kaggle. And if you have it in the same folder, your path is just this. If you have it separated, if you have marketing campaign XLS6 in some other folder, maybe downloads, you have to put all path here, so user, desktop, or something. But if they are in the same folder, you will just type this, like me. We imported pandas, so this is not necessary here. But if you don't want to import all the libraries here, you can import one by one. So this is just unnecessary input. We have it here. Then we wanted to load the file. So to read the Excel file, we use the command read Excel. If you have CFC file, you will type just read that type of file, but here we have Excel file, and that command is just for Excel. In this command, the first parameter is the path to the file, as I told you in the last minutes. The second parameter is if the first or second or third row contains column names. In our table, the first row contains all the column names, so header is 0 because of it. The third parameter is sheet name, and in Excel file we have only one sheet, sheet 1. If you have more sheets, you will just type the sheet where your data is, but here our sheet name is sheet 1. So when you type this and run, in df parameter you will have all the data loaded, and df is our data frame. This command, next command, df.head, shows the first 5 rows by default, but if you specify some number in between the parentheses, you will see more than 5 rows. You can type 10 to see 10 rows, 15 to see 15 rows. When I run this code, first the data will be loaded in df, and then we will see the first 5 rows, and here it is. We have all the column names, and then we have 5 rows. If I type 10 here, we can see the 10 rows, of course, but the default is 5. Okay, so we can see all the data from the Excel file. Then we can see what we can do with all this data to see some information, etc. The first step for this overview is to see the info. So with the command .info, we can see information about all these columns and data in it. We have data types and non-null values. The first is non-null count. So we have for about 20 to 40 non-null variables in all these columns, but we have one income where we don't have all this non-null values. We have 20 to 16 non-null values, and we will see how can we change this. And the data type is here. We can see our data is integer or object or floats, etc. The next step is to see maybe all these data types listed here. We don't have to type info. We can just say, I want to see all my data types, and we can do it with the command dtypes. When I run this, I will see all the columns and their data type. And you can see that for year birth, it is the number, it is integer, but for education, we can see that it's object, some string, because we have some text in all these rows. Then, when we checked our types, we can check missing values and sum all the numbers. When we type df, that is our data frame, dot is null, that means is null. We just check if the instances in rows are missing or they have some data in it. And when we type .sum, we just sum the number of missing values. And here we can see that we have 24 missing values for income, and all the other columns are okay. They have all the data in every row, every column, every instance. So with this, we know that in income, we have some missing data, and we have to do something with these places. We choose to drop rows with missing values. So we use dropNav function, and we just type df, that is our data frame, dot dropNav. That means we want to drop all the missing values, and we said that our data frame is now the new data frame with all these missing values deleted. So we have to say df is df.dropNav, because if we just type df.dropNav, it will change our data set, but we can't see the difference. It is not in our concrete df data frame. So when I run the code, now I will have all the missing values deleted. When we do everything with missing values, we don't have it anymore. We can check if we have some maybe duplicated rows. So here I checked where some rows are duplicated or not. And I used df.duplicated to check if it's true or false, so if it's duplicated or don't. And then I sum all the duplicated rows, and I got a number 0. So we have not any duplicated rows. That is okay, and we can go to the next code. Then I checked the number of unique values in each column of the data frame with n unique number of unique values. And I run this code and get all these numbers. So for ID, I have 2216 unique values. That is okay because I have that much instances in our data set. For year birth, I can see 59 values. For education, 5. For maybe response, I have 2 because my response is true or false, and that is also okay. So that is the number of unique values in this data set for every column. Then we have a function called describe function, and when we type df.describe, and I run this, I will get all the information that describes my data set. First is the count variable. The count is number of non-missing values. So because I deleted all the missing values, for every column, it is this number, 2216. After count, we can see the mean, that is average value for every column. So for the year of birth, you can see that the number is about 1968, and that's the mean year of birth for all the customers. For teen home, that's not the best example because you can have half a twin, half a teen or half a kid, but you can see that some of them don't have kids or teenagers, some of them have it. For maybe income, you can see that the mean income is this number. After, we have standard deviation, that is STD, and that is measure of data spread. So you have data spread for all these columns. Minimum stands for minimum value. So we have for ID, of course, minimum is 0. For year of birth, you can see that is this number. For kid home, minimum is 0, of course. For, I don't know, maybe accepted campaign, 0, etc. After, we have percentiles. We have 25, 15, 50, and 65 percentile. And 25th percentile means lower quartile. That is 25% of data that is below this value. For the median or 50% or percentile, that is mil value of the data. So the mil value of the data for year is maybe 90, 70. For the income is this number here, etc. After we have 75th percentile, that is upper quartile. We have lower and upper. And for this, 75% of data is below this value. So you have the data that is below this value, and this value. And the last one is maximum. That is our maximum value. So you can see that the youngest customer is born in 1996. And you get just this statistics by typing df data frame dot describe. And that can be useful for maybe some just thinking about this data set, what you can do with all this data and what you can use. After we described everything, we can see the dimensions of the data set, and we use library NP NumPy. That is our pseudo. We used NumPy as NP, so we just have to or can type NP. Dot shape returns a tuple. We have, when we run this code, we have rows in our data frame. We have 2216 rows and 29, that's the number of our columns. So we have 29 columns, and that's not our table, but 29 columns, and all the data are listed in 2216 rows when we deleted all the missing values. So that's our final number, and we use dot shape. After we saw the number of rows and columns in the data frame, we can maybe delete some columns or add some columns. First, I added a new column called age. So you can add a new column by typing df, then parentheses, and age in between. Just the name, how you want to call some new column. And I called it age. And our age is the difference between the current year, the year that is now, and their birth year. And we just get the number of how they're old. So PD is another library we imported. Pandas, we used it as pseudo PD. Dot timestamp dot now returns current date, today's date, and dot year just shows year 2024. And when we get the difference between current year 2024 and their year of birth, maybe 1996, we will get how old are they for every instance in our data set. So I run this code and I can see when I just, oh, sorry. I can see that some of them are 67, some of them are 40, some of them are 70, etc. So that's their age. Then I added a new column called days, and the days column are based on the number of days between the current date and the date when they signed the contract. So I also used the date that is current now from pandas.timestamp. I got the difference between current date and DT customer. That's the date they signed the contract. And I just type .tt.days to get the count in days. And I put it in this column, df of days. And I can see how it looks like now. and you can see the count in days. After, we have some column DT customer, that is the column here, but the values here are not in date time format. They're objects, meaning they're strings, some kind of text, but I want to have it in date time format. So I use PD dot to date time to convert the data from text to date time. And when I run this code now in this column DT customer where I had some text, I have date time format. And that is necessary for the next steps. Then I added also a new column called spending. And as I told you previous, we have some numbers for spending in for vines, for fruits, for meat products, for fish products, for sweet products, gold products. And I just wanted to sum all these spendings and put it in one variable. So I created spending column and I summed all these spendings. So when I sum all this, I have all the spendings in this column and I run this. When I run this, I can show you how it looks like in the data frame. Yeah. And you can see the spending in dollars here. Then I used M&T wines, M&T fruits, etc. I have it all in spending, so I can drop all this. I can delete it. I don't need it anymore. So with the dot drop, the f dot drop, you can drop whatever you want. I want to drop a list of all these columns. And for axis, I chose 1 because it operates along columns. If you want to delete rows, you will type just axis is 0, but I want to drop all these columns and all the data in this column, so I type axis is 1. And the first parameter is this parameter, a list with all the dropping columns. So I run it, and in my data frame, there is no more M&T wines, fruits, meats, fish, sweet, and gold products. Then we calculated the age of each individual based on their birth year and the current year. That's the same as this. Yeah. And also we calculated the number of years since each customer was enrolled. So this current year and DT customer is the date that each customer enrolled. And I got just the number of years and I called the column LSC. Then I can show the info of the data set now. It is different than the first info. So now we have 26 columns. We have some new columns, as you can see, age, days, spending, LSC, and some old columns. And also we don't have any missing value. You can see that is the same number for all the non-null counts. You can see the same number in each column. And for data time, you can see different data type here. For DT customer, we had object, I guess, but now we have date time objects, date time type. Okay. Next, we have some columns like set cost contract, that is this column, set revenue, that is this column. We have year birth, okay, and we have DT customer. DT customer, here it is. So set cost contract represents the cost of contacting the customer, and this data is not relevant for the analysis, so we just wanted to drop it. Set revenue is revenue related data, also not needed for this analysis, so I also dropped it. Year birth, this column, as I told you, represents birth year, but it is also not necessary, so because we have their age and we don't need it anymore, so we can drop it. And the last one is DT customer. You know that this column contains the date when the customer joined, but we counted all necessary numbers like days, like LSC, and we don't need DT customer anymore. So I just dropped all these columns with df.drop, and the first parameter is a list of all these columns I want to drop. Set cost contract, set revenue, year birth, and DT customer. And for axis is of course 1, because all this data stands for columns. So I want to drop columns, and axis is 1. For rows, axis is 0. And then when I dropped all this, I wanted to make sure everything is okay. So I just type df.head, and I can see my data now. I have ID, I have education, marital status, income, kid, home, teen, home, etc. But I don't have this data specified here. And I can maybe print my columns with df.columns. I get all the names of my columns. Now I have all these columns listed, and that's my final look. After we saw everything we can see in Python for our data, maybe we can see whether our columns are numbers or whether our columns are categories. And first, I checked the data type of number for all my columns. With df dot select the types. The parameter here will tell Python, okay, I want all numbers, all the columns that contains numbers, and with dot columns, I will get their names. Also for categorical columns, I want for my data frame df to select data types object, because object stands for text, string, and I want to get my columns, their names. And with this commands, I identify numerical columns here in df_num, and object related, so category columns in df_cat, categorical. After this, I run this, and I have df_num. I can show you. df_num ID, that was all the numbers. Income, that was all the numbers. Kid home, teen home, recency, that was the numbers. So that is okay. And for categories, I can see we have education and marital status. That were the strings. We had PhD, masters, etc. And we there had husband, married, single, alone, etc. So we got it right. Then, not all these numbers are what we need. So we want to have 2 types. We want to have continuous columns, numerical data types, but as continuous features, like income. And here, we want to have categorical columns, not only strings, but also columns that has types like true, false, or categories like 1, 2, 3, or some other types of categories like married, not married, etc. So we want just to make sure that we have 2 types, continuous columns and categorical columns. So first, we just use our previous commands and what the data we got in dfnum and dfcat. And after this, we defined features that should be treated as categorical regardless of their data type. Because accepted campaign tree 2, 5, 1, 4, complaint and response are numbers, but they're not continuous, they're categories. Because for accepted campaign 1, 2, 3, 4, 5, we have true or false, whether they are accepted or not. And for response, we have true or false, 0 or 1. So they are for sure categorical, they are not continuous. So we just wanted to make sure all these categories are listed in our categorical columns, and we looped through categorical features one by one, and then we just checked if this categorical feature is in our continuous columns list here. If they're there, okay, we don't want any categorical feature, any of these features anymore in continuous columns because they are not continuous. So if they are, just remove this accepted campaign or accepted campaign 2, 3, 4, etc. But if they some categorical feature is not in categorical columns and they have to be, just append this categorical feature. So here I showed you for continuous. I have ID, I had income, that is okay, but I have accepted campaign 3, 4, 5, 1, 2. These are not continuous variables. So with this if, I just remove them from continuous, and with this if here, I just put it in the next list called categorical columns. So when you run this code, we can see the difference. So all these columns are removed. That's our final look for continuous columns. And we can see the final look for categorical columns. That's it. Education, marital status, all this accepted campaigns, complaint, and response. And now we have listed what we needed for the next steps. So the next is exploratory data analysis. And here we have to explore how our data, what they do with one another and how they respond to one another, etc. The first is heat map. A heat map is, as you can see, a data visualization tool that uses colors, and you can color it wherever you, whatever you like. And with colors, we represent values in a matrix or table. It is used to show the relationships between all these variables. So the relationship between income and recency, income and complaint, accepted campaign 1, 2, 3, 4, and day stage, etc. All these correlations and relationships. The color indicates the strength of the correlation. If it is darker, the correlation is smaller. And if you have this colors like lighter red, pink, the correlation is bigger, stronger. So we can visually see patterns and relationships between all these features in the data sets. So first, we have to create a figure for the heat map, and I use plot, that's library, dot figure, and in this parentheses, I just type fig size and the size I want for my table, for my matrix. You can choose the size and adjust it in as you like. So I chose this, but you can type maybe some other number, maybe larger or smaller. After I plot the figure, I have to just get my heat map. And to plot the heat map, I used SNS, that's the library, .heat map, that's the function, and here heat map generates a heat map visualization of the correlation matrix, what you can see. Then we have data frame, our data frame .core, that computes the correlation matrix showing the relationship between numerical features. All the correlations between our numerical data. After .abs takes the absolute values of the correlation coefficients to show the strength of the relationship, because when we just get df.core, we can get negative signs. So we don't need any negative sign. We want all to be positive. So we just use .abs to get all the positive data from these correlations. And for annote is true, that adds all these numerical correlations. Without it, we will just see colors, but with annotation is true, we can see all the numerical correlations values on the heat map cells. And that's all. Just plot the figures, change the fig size if you want. I chose this size, and then from SNS library, use the function heat map and put some parameters in between. You can type just df.core. It is okay if you want negative numbers. I just wanted positive numbers, so I used absolute function. And then I also wanted annotation, and because of this, the annotation is true. When I run this, I will get the same heat map, but we have to wait a few seconds. And you can see our heat map. You can see that the correlation between ID and ID is of course 1, because that is the maximum correlation. And when you have correlation between the same variable, it is of course 1. And we can see that maybe here the correlation between spending and non-catalog purchases is 0.78. That is high correlation, so they are highly correlated. But when we see maybe this, in between recency and accepted campaign tree, we have very low correlation. So they are not that much correlated. So you can see for all these columns how are they correlated, and you can just think about it and see what you can do in the next steps, and what you can maybe delete, or what variable you can use with maybe some correlated variable, etc. And that's the heat map. Then I think you all have classes for data visualization, and of course I have to visualize all the data to show you what we can do. Maybe you know all this, but I will just do it again for our data set. The first data visualization type here was scatter plot. I used scatter plot. Scatter plot displays individual data points as dots on a two-dimensional graph. Each point represents a pair of values from two variables. Here is for spending and non-catalog purchases. Scatter plots are useful for identifying relationships or some patterns between variables such as strands, clusters, or outliers. The position of each dot shows the value of the variables being compared, and everything I just told you, you can see here. I created a scatter plot by sns.regplot, and with this function, we can create scatter plot. In between, first parameter is x spending. It specifies the variable on the x-axis. We can see on x-axis we have spendings, so it is okay. For epsilon, we specified the variable on the epsilon axis, that is the number of catalog purchases. So we can see that we on the epsilon have non-catalog purchases. And for our data that are we using in this plot, we just use our data frame df as in previous commands. And when I run this code, I will have the picture of this graph scatter plot, and I can see all the spendings and all the number of catalog purchases for the spendings. And okay, that's okay. Also, here we have a regression line, and it is blue. It is not well seen here, but we have some regression line by default. If you don't want that regression line, you can just type fitreg is false. So with this command, you will get just dots, not any other line. But regression line is okay to just have it and maybe see how it all works. After we use scatter plot, we created, do you want to have a break? I guess we have to take a break now. It is 11:45. Can anyone hear me? Okay, so you have a 15 minutes break and then I'll be back. Thank you. I guess we are back. Can you hear me now? And do I have any noise? In the background, I just saw the message from...
I heard you and the noise is
Okay, everything is okay now.
right?
Okay, thank you. Do you have maybe any questions, or do you want for me to slow down or something? I don't know if everything is okay. Just tell me if you want for me to maybe slow down or something. I don't know. Um, I thought that you have my documents, and I don't have any way now to send you, because it is my file in the Visual Studio IPyne file. So here I think I don't have any way to send you this. No, but I will send you all my files after the lesson. So, okay, so you will have it all, and you can contact me for every question. So we can now resume the lecture, so I can turn off my camera and share my screen. Okay, share. So, can you see my screen?
Yes.
Okay, thank you. And we saw the reg plot, the scatter plot. Now we can see other scatter plot, but for different data. Here we chose to see the scatter plot for spending on the x-axis and kid home for the epsilon axis. And we can see here better the regression line. So just with dot reg plot and specifying the x and epsilon, data is our data frame df, we can see the scatter plot between the spending and kid home. So we can see if they have 0 kids and they didn't have kids, the spending is large, big. But if they have maybe 2 kids, you can see the spending is lower. So as in nature, more kids, less spending on ourselves. Strip plot is the next plot. It visualizes individual data points along a single axis. Here's the single axis, and showing how a continuous variable like spending here is distributed across different categories. Here we have 1, 2, 3, 4, 5 categories, and these categories are from education level. Each dot on this plot represents a data point, and here we don't have any overlapping dots because of a thing called jittering. And it is applied here, so by default, and it is making the distribution much clearer, so you can have this clear look. Here we use catplot for a strip plot. So SNS is a library, .catplot is a function for a strip plot, and for parameters, the first one is x, it stands for education, epsilon is for spending, and kind of graph is strip. So everything is stripped, and the data is our data frame. And we can see that for maybe graduation, the spending is large. For PhD, it is large, but maybe less than graduation. For master education, it is the same, but for basic and second cycle, that's lower level of education, they don't spend that much like other that has higher education, that have higher education. Okay. That is CarePlot. We have other one, CarePlot for kid home and spending. So we use CarePlot, but for X we had kid home. For Epsilon we have spending. And kind is also strip. Data is our data frame DF. So we can see for 0 kids spending is large, for 1 kid smaller, for 2 kids spending is low. After we use CarePlot for the number of teenagers at home and their spending, customer spending. And we can see like kids, if they didn't have any teens, the spending is bigger. When they have 1, the spending is lower, and for 2 teens, it's the lowest possible in this plot. We use CarePlot also for Marshall status and spending to see how spending, how are they spending when they have a wife, girlfriend, or maybe a husband or boyfriend, of course, or they are single, alone, or you only live once. Okay. That was all the data from our Excel file. And you can see that if they're single, the spendings are large, together also, married also, but if they're alone, they don't have actually any spendings, just a few dots here, around 700 maybe. So that's for Marshall status. After we use CarePlot here, that was strip, now scatter. Scatter plot is a type of graph that displays individual data points as dots. So we have all the dots, and every dot is showing the relationship between 2 continuous variables. So we have spending, that is continuous variable. We have income, that is also continuous variable. And the dot is a relationship between this continuous variable and this continuous variable. Each dot represents a pair of values, one on the x-axis and one on the y-axis, as I told you. Scatter plots are useful for identifying correlations, trends, patterns, outliers, etc. So we use the function called regplot from SNS also, library SNS.regplot. And for parameters, we use spending, that is the variable on x-axis, and it's like in the previous examples, spending, customer spending. For the y-axis, we used customer income and, of course, our data frame. So we visualized how income correlates with spending. And here we also have regression line, the trend by default. And we can see for every spending, maybe here, if maybe for this income, we can see the spending, just check a dot. After, we used histogram. A histogram is very popular, and I think you all know histogram, not just from programming, but for other types of learning. And it is a type of graph that shows the distribution of a continuous variable by dividing the data into bins. And you can choose how many bins do you want, and displaying the frequency of data points within each bin. The x-axis represents the variable, and here on the y-axis we just have the count. So the y-axis represents the number of data points in each interval. And here we for the x-axis, we used income, the customer's income. For hue, we used Marshall status. So we have 1, 2, 3, 4, 5, 6, 7, 8 different categories in Marshall status, and all our data is separated through these categories. So we used his plot from SNS. For the data, we used our data set DF, data frame. For x-axis, we used customers income. For hue, all these colors are actually categories for Marshall status: single, together, married, divorced, widow, alone, absurd, YOLO. And we used multiple stacks are histogram bars allowing the visualization of the distribution of income across different Marshall status categories. If we didn't have this stack, I can show you how it looks like. It's better with it. Just a second. Yeah, you can see that it's better with stack. Yeah. So that's the histogram for our income based by Marshall status. After, we also used his plot, but for age by response. Response is 1 or 0. Have they responded or haven't they? And we use SNS.hisplot. Data is, of course, our data frame DF. X-axis is age. Hue is response. Response is 0 or 1. Have they responded or they didn't? We have 20 bins, so 20 these different bins, and multiple is stacked, so it looks the way it is here. And when we run this code, we can see the final look, how age is influenced by, so how response is influenced by the customer's age. Then we used his plots for income and response. So we also have income here, but response as hue, and X is income, hue is response, 20 bins, also multiple stack, and we get this picture. After we used his plot for recency and response, recency here, response is hue, and all other is the same. So we visualized how recency is distributed among those who responded and those who did not. The next is his plot for age and complaint. So this histogram helps to visualize how age is distributed among customers who complained and those who did not. We can see that there are not many complaints, so it's okay. Then we used his plot for spending, and we colored it for complaint also. So we can see just maybe one complaint here, and they have low spending, as I can see there, this orange bin. After, we used his plot for income and also colored in the colors of complaints 0 or 1. And we can see how income is distributed between customers that complained or they didn't. And that's the last for our his plot. You can choose different columns here, and just play with all this. You don't have to use it in the way I use them. So just play with all these variables, all this data, and see what you will get. The next chart, the next plot, is actually the pie chart. And it is also popular. It looks like a pie. So it is a circular data visualization used to show the proportions of different categories. So I can see just the proportion of maybe one category in all this, or multiple. each slice of the pie represents a category, and the size of each slice is proportional to the quantity of that category. And of course, they're used how a whole is divided into parts. So we first wrote this line of code. It contains of multiple lines. So we have this. This line counts how many customers responded, labeled as 1. When I have in response column an instance of 1, that means the customers responded. And I just wanted to count this. I got df of response, so the column response. I questioned if it is 1. If the response is 1, okay, I will get the response column from the df, and then I will count how many rows I have in the response columns that are 1 for the response. And when I found all the ones in the column response, that's it. That's the first data here. After, I questioned if I have any response that is 0. Okay, I found all my responses that are 0 in the rows of the column response. And after, when I found them, from the data frame df, I got the response column with all the zeros. And after I got the column with all the zeros, I just counted how many instances I have. And here I get the number of how many customers did not respond. So now I have the data for the pie. Categories are 0 or 1. As I told you, 1 is if they responded, 0 is if they didn't respond. And when I have categories and data, I can create a pie. Plot, library plot dot pie is used to create a plot for the pie. And first parameter is data. That's our data here. So we have how many people responded and how many didn't. That's data. For the labels, we used categories and labels as 0 and 1. As you can see, 0 and 1. This auto PCT is just formatting. We wanted to display the percentage with 1 decimal place, and we want to have %. That is just formatting. So you can format whatever however you like. So you can have maybe 2 decimal places, 0 decimal places, with or without this percentage, etc. And the last one is start angle. You can choose where you start. I choose that the start angle is here, but you can type 0. If I type 0 here, I want to start with 0 angle. This pie will look like this. Or if I want to start here, I will have this look. So it's on you. I chose to be 90, and that's my final look. After, I just wrote a title, plot.title, and my background is black, so if you have a white background, you will see it better when you got all my work. But here I just wrote a distribution of customer labels, 1 or 0, just some title. And the last step is to show the plot. Show the plot, and I just type plot, that's library.show, and it shows and renders the pie chart to my screen. So I can see that Here is the 0. It's not very good because it's black also, but you can see that 0, so 0 is not, the customers did not respond, is 85%. So a lot of them did not respond, but we have 15% of the customers that responded. And that's the point of this pie. So you can choose different variables, maybe different values here, etc. Just play with it and got maybe some other pie. That's the pie. Okay, so I wrote here that we have, okay, that's what I told you. And okay, that means that the number who received the promotion was much less than those who refused, and we can see from the proportion. The next step is outlier detection and removal using interquartile range IQR. I chose to use this interquartile range because it is very good and it is not terrifying like maybe some other outlier detection methods. So that's some for the beginners, and you can get all this with me now. So what are outliers? Outliers are values that are significantly different from most other data points in a data set. And because they're different, they can negatively affect statistical analysis and machine learning models. And this is one method for their detecting and their removing. IQR is the range between the first quartile, as I told you, it's 25%, third quartile, that is 75%. You learned it in the start of this lesson, and it helps us understand the spread of the middle 15% of the data. So, what are the steps? First, we have to find the first quartile, Q1. Q1 is the value below which 25% of the data falls. It's 25th percentile. That's the first. After we find first percentile, we have to find the third. Q3 is the value below which 75% of the data falls. So it's 75th percentile. After we got the first, the third, we have to calculate the interquartile range. So it's just the difference between Q3 and Q1. Q3 is bigger, so it's the first, and Q1 is smaller, so it's the second. So IQR is just the difference between Q3 and Q1. After, when we have all these limits, we can define normal data range. It doesn't have to be just Q1 and Q3. It can be maybe a little on the right or on the left. You will see on the picture. So I chose lower limits to be Q1, that's 25th percentile, minus 1.5 of IQR. And for the upper limit, I chose to add to Q3 maybe just a little, plus 1.5 of IQR. And any data points below the lower limit, so on the left and above the upper limit, so on the right of the graph, are outliers and they are not good for our data, so we have to remove them. The final step is, of course, to remove all the outliers, and so data points outside the range of the lower and upper limits are removed, and their extreme values and could distort our analysis. So the best is to remove all of them. Here you can see why is this method good, easy to apply. That's the first, robustness, etc. And you can clean your data set and ensure that the outliers did not affect any results and everything is as it has to be. One example, if you didn't understand any of this, is this example. Imagine you have a data set of students' exam scores. So the scores are between 15 and 19, and 50 and 90. We have a few students that are scored below 20. That's extreme value on the left, and scored above 100 that are extreme value on the right side. So these extreme values, 20 and 100, are outliers because very much of them are between 50 and 19. So you just have to remove all of them below 20 and above 100. And the IQR method just does this. We calculate Q1, that is 20. We calculate Q3, that is 100. So if we have 15, that is our Q1. So 50 is Q1. Lower limit is a little less between 15, so that is 20. After we have Q3. Q3 is for us 90, and 100 is this upper limit, just a little more than this Q3. Yeah. So when we have our range, all the values that are below 20 and above 100 are outliers, and they have to be removed. And everything I told you now, I wrote in this code. First, step by step. Here's the function def outlier, and we first have to count the Q1. That is 25th percentile. So for my data X, just let me see where I call this function. Function is outlier, just to tell you what is X in this read outlier neo. Yeah. We just send some data from our data frame. So here in the next steps, we send the data from the data frame and use the data with this variable X. And now when we have our data in the variable X, we have to calculate 25th percentile with NumPy, that's the library. NaN percentile is a function where we send the parameter. The first is the data that we use, and the second is which percentile we want to calculate. The first is 25th percentile. So here in Q1, we have the data of the 25th percentile. After we calculated the 75th percentile, Q3, in the same way, we just have to put 75 in between this parentheses as a second parameter. When we have Q1 and Q3, as in previous steps, we have to calculate interquartile range, IQR, and that is just the difference between Q3 and Q1. And in this variable, we have their difference, the data in between. After we have all this, the third step is to calculate lower fence and to calculate upper fence. Lower fence is Q1 25th percentile, but just a little on the left side, just a little less. So we just subtract 1.5 of our IQR. So this value multiplied by 1.5. Upper fence is Q3, but just a little more. So we just add to the Q3 this value, 1.5, multiplied with this value IQR. That's what we learned in the previous steps. That's all I told you, but in Python. After we have two lists to store outliers and not outliers. So outlier is for all the outliers and non-outlier is all for the good data. So I iterated through the data sets and I had to identify outliers. I go through the X is my data, one by one. I store every instance in my num. And when I store an instance in num, I just ask if my instance, if my data is lower than lower fence, or if it's bigger than upper fence. If it is, it's an outlier for sure. So I have to append it in the outlier array. If it's not, if it's in between, it's okay. So just add to this non-outlier list. And with this iteration, where we iterate through all the data sets and ask if the data is lower than lower fence or bigger than upper fence, we just find all the outliers and all the good data, and now we can do whatever we want with these values. Here, I just printed the sum of unique outliers, how many unique outliers I have. With len, that's the length of the array. Set of the outlier will get all the unique values in one set. And because in this outlier set, maybe I will have duplicates. And with set of outlier, I just make sure to have just unique values in my set, and then just get the length of my set to see the sum of unique outliers. After I printed the count of unique outliers, I printed the lower and upper fence values. That's this lower fence and upper fence values, just to see it printed. And we have none outliers, so the values that are good, and we wanted to see the value that is a minimum for good values and the value that is maximum for our values, and we used NumPy as library and minimum and maximum as a function to just have it all counted, minimum and maximum. And the last step is, of course, to return all the values. We returned lower fence, upper fence, outlier, non-outlier. Maybe we will need these values in our code in the next work. And this function is used to identify outliers in the dataset. It calculates the interquartile range for a given numerical variable x and defines the normal data range, and that's the normal data range. As I showed you, any data point outside this range is considered an outlier and can be removed from the dataset. Okay, and we have to see how it looks like. This is just everything you will see, so I will return on this. Okay, and here we just use our function. We just get our data in this list and go through everything how we want it to be written and showed. So you just can copy this code and run it. It's just how it will look like here. So that's it. I will not run it here because this code is running for an hours in the last lessons. So if you have some trouble with it, it's not code or anything, it's just time. It needs time to run and to have all these pictures, because you can see there are a lot of pictures here. Okay, so when I run this function for interquartile range and outliers, I will get these pictures. And as I told you, maybe I can't. That's a good text, so I would like to show you a picture and all this okay, maybe. Okay. So here we have our plot based on our function from above, and this box here represents the interquartile range. First, we have our medium, we have our Q1, and we have our Q3. And we have this red lines here, and that's some limit for Q1, medium, and Q3. Yeah. Then we have something called whiskers, and that looks like whiskers here and here, and that lines represents the range I here wrote. That's this 1.5 times the I² in minus and in plus. That's the limits for our outliers. And as I go back there, that's lower fence. So lower fence is here, lower fence, this whisker, and upper fence is this whisker here. So everything from the code is just there. Q1, Q3, lower fence, upper fence. Yeah, and every value from here, so lower than whiskers and bigger than whiskers here, is an outlier. Here we can see that we don't have any outlier because all the data is in this range and it is good. But maybe here we can see that we have Q1. Okay, first red line on the left. Second line here is Q3. After we added this 1.5 of interquartile range, and we got whisker on the right and whisker on the left, and we got this range. So every data that is higher or lower than whiskers is an outlier. Here we can see how many. Here we can see 8. Okay, it's not visible that good, but we can see these points here that are, of course, outliers, and they will be removed, and this point here. Okay, then maybe for this picture, okay, there is no outliers, maybe some better. I can, okay, here. Here we can see also Q1, Q3, whiskers, outliers. All these outliers, these dots, will be removed. And some of unique, here, some of unique outliers are 8. Lower fence value is 2. Upper fence value is 6. Okay. Minimum not 2. Yes. Serbian and English. Okay. Minimum non-outlier value 0. Maximum not outlier value 6. Okay. Data skewed. The skew, but you didn't need to know the skew, and data not normal. Yeah. So you can just see all these pictures and think about what I told you. So we have Q1, Q3, we have some whiskers, and everything that is not in between is considered as an outlier. I hope you understand me. So outliers, as I wrote here. I can go back to the conclusion of all of these images and everything. It is not that hard as it looks like, maybe. So, conclusion. Outliers, as I told you, are points that fall outside the red lines, upper and lower fences in both the box plot and histogram, but with whiskers. Outliers in the box plot are clearly visible as points above the upper red line and below the lower red line. In the histogram, outliers are those extreme data points that fall outside the blue dashed lines. So we can see it all here, but when you see that dots that are somewhere in these places, that's an outlier. This one, this one, this one, okay, is the same. This here, this one, okay, etc. Okay, print the list of normally distributed columns. We can see that we don't have any normally distributed column based on our research and our code and our data. And that's all for the outlier value. Here is the everything for the next lesson. So I guess we can have a break now because that's the other section. And we will have 4 minutes more. So I guess I'll be back at 13. Is it okay? Yeah? You have 20 minutes. Yeah. Okay. Thank you. Hello again. And now we have the last section. I hope you can hear me. I guess you can. Okay. Thank you. And that's the last section. We finally have to do something with all this data and everything we have done until this moment. So we just have to put all these columns and data and everything into something that we can use for this models. So I choose to have some variable called dummy, and there we store all the columns from the data set without the response column. Why? Because the response column is our target variable, so we just put all other columns without the response. And we also chose that we want just the columns that has fewer than 20 unique values. So we deleted all the values that has maybe 15 or 10 or 5 instances, just because we get better results with it. So you can try with without this. You can delete it. You can try and see the results without this. You can type.
Sorry, sorry, is your screen shared?
Oh, no. Sorry. Yeah. Thank you.
Thank you so much.
Thank you. Okay. Now it is. Okay. So what I wanted to tell you, we have a dummy variable, and I stored there my columns, all my columns, but without response. The response column is our target column. We get the response. That's our final result. So for our dummy column, we just choose all other columns. And we get every column from our data set without response. We dropped response here. And we choose that we want to have just the columns that have a minimum of 20 unique values. If they didn't, okay, they are not good for us. Our results will be worse. So that's the point. You can delete it and try without it. You can put some other number, maybe 10, maybe, I don't know, 100. You can try with different numbers, but this number works good for me in this lesson. So here, everything I wrote is stored in the dummy variable. After, we have to convert actually the dummy to dummy variables. Dummy variables are actually binary columns, so 0 or 1. I want to have in all my columns just 0 or 1, nothing else. No string, no, I don't know, objects, etc. I just want binary columns, 0 or 1. So my columns are now, I can show you how our data set now looks like. But I have to run this so they change. I can just show you maybe. Here we have, okay. So I want for education to have 2 columns, education 0, education 1, education 2, etc. So education for graduation, education for PhD, education for masters. And in each column, I want to have 0, 1, etc. So education I have maybe a column education graduation, and in this column where I have graduation, it's 0 because it is that value. But in this, we can just think about this column as its education graduation. For this column, it's not graduation, so the value will be 0 here. So there will be 1, 1, 1, 1 because it is graduation, but there will be 0. What I want next, I want a column called education PhD. And the values in this column will be 0 because it's graduation, not PhD. Here, 0 also because it's graduation, not PhD. 0 also, 0 also. But here, the value will be 1 because in this line, education is PhD. And you will see it's in the next steps. And that's called dummy variables. So we just have values 0 and 1. And many columns because we have to write all these possibilities. So where I am here. Yeah, so we got dummies with pd library dot get dummies. That's the function. We send our data frame. That's the first parameter. For columns, we used our dummy columns, so all the columns but not response. And drop first is true. Why? Because that parameter ensures that we avoid the dummy variable trap by dropping one dummy column. Yeah, we want to drop every first column, so because of it, it's true. You always want to drop first, so you always write drop first is true. And for D type, we use this, and that's efficient memory usage for binary columns, so it's also necessary for every get dummies you write. So this is by default, and here we just send our data frame and columns we want to change to get our dummy columns. And when we do this, we just write this command df.info to see how our data frame now looks. And we can see that we have many more columns, 98. You have, as I told you, for maybe education, yeah, we have education basic, that's the first category, education graduation, that's the second, education master, education PhD, and in each column you have just 0 and 1. Where the value was basic, there in this row you have 1 for basic. Where the value for education was graduation, in the column education graduation you will have 1 and 0 for every other. And in education master, where you had master in the education column, in this row you will have 1 in the column education master, and the last is education PhD, as in previous, where you had PhD in the education column, you will have 1, and all other values for other rows where you have master or graduation or basic will be 0. So that's the point. That's the point for every other, and that's why we have all these columns listed here. And now we have our data set prepared, and we can do something with our data. Now we have DF as our first data frame, and everything removed and everything checked and prepared. But now we want to separate it to X and Y. And you do it every time. You have to prepare it to have X, that's the columns that are not our target variable, and Y, that's our target variable. And that's what we do here. So we created a new data frame X and removed response. Why? Because response is our target variable, and we want in X every column that is not response. So we dropped it. X is 1 because we want to drop column and everything in this column, all rows. and we store it in X. And now we can use X for our input. So when we created X, we have to see the data in X. We just wrote x.head. Previously, we typed df.head, but now we have X as our new data frame. We can type df, of course, but that's our not target here. So when we type and run this, we can see all the columns for our input, our X, and that's all the columns, but not the column response. For the epsilon, we just chose to be response. Why? Because we have just one output, and the output is response, whether they responded or they don't. So we said, okay, epsilon is just the response column in the data frame, and that's it. We displayed the epsilon here. We just have one row, so that's ID, and that's just one column here. So we can see that we have just 0 or 1. They responded or they did not respond. When we have our X and epsilon, we can train test split here. So we split the data set into training and test sets. We have X train, X test, epsilon train, epsilon test, and we do the split with train test split. We previously, in the first step, imported from the library this function train test split, and the parameters are there. First, we have X, that's all our columns, but not the response column. The next parameter is epsilon, that's just our response column, so just the target variable. We choose the test size. You can choose different numbers, but I chose that the proportion of the data set to include in the test split is 20% in this case. You can type 30%, 40, but 20, 30 are some basics. And the last one is random state. It's 42 in this case, and it's just a seed. And with this random state, every time I train test split and I run this code, I will get the same lists here and here and here and here. I will not have any differences, so it's the random state. You can choose different number, but I chose 42, some number, random number. And when we do this and run it in X-train, X-test, epsilon train, and epsilon test, we will get our data. And after we just printed data shape with this is formatting. F is for formatting in Python, just the text, parentheses, and under our variable xtrain dot shape is a function to get rows and columns, the number of rows and columns. Training target shape, epsilon train, our previous variable, and dot shape for rows and columns, their number, and X test and epsilon test. And we can see that we just split our data into two different lists. So for X train, we have 1772 instances, and for epsilon train, we have 98. For test data shape, we have 444, and for test target shape, we have 90. Sorry, this is all for training test shape. So we have that much columns, rows, and that much columns. And here we have that much rows and columns. That's for X. This is for training. 20% is for tests, so that's this number, 20% of 2,000 data, instances of data. And for training, we have this shape. So epsilon has just one column, so we have just a shape like this. So we have 17 72 instances in training, and for test we have 20%, so 0.2, and it's 444 in this case. So we just printed all we got there just to see, is it okay? Is it the proportion good? But I guess it is for this data set. And we have to evaluate our data. Here I wrote the evaluation function, and here what my evaluate function does. We have the model, X test and Y test. We send it to our function. Model is the trained machine learning model to evaluate. So in the next steps, I will use different machine learning models and we will evaluate their performance. We send X test and Y test. That's what we have here. And after we predict labels for the test set and display the confusion matrix, accuracy score, etc. So Y test predictions. So our predictions on the data test set, we get them with predict function. Model is our model. We will see the model here. So our model is, for example, logistic regression model. So when we send this model, I will send it here. I will get it there. And I will say, okay, for logistic regression, predict me the results, epsilon, for my tests in X. So in X, I have tests examples, and I want to have my prediction in Y test. And when I get my predictions, I can see if it is good or it isn't. And I just printed results on the test set. I use confusion matrix. That's a matrix I will show you in the next steps. And confusion matrix, we just called the function confusion matrix. We imported it in the first step. And for the first parameter for confusion matrix, we have Y test and Y test spread. We just evaluated the performance with saying if Y test is like Y test prediction. And we confusion matrix shows true positives, false positives, true negatives, and false negatives. You will see it in the next lines. Then we printed the accuracy. We used accuracy score, and we send it here Y test spread as in previous, and just see if it's accurate, if it's the same or it's not. And this is for formatting. I want to have 4 digits after decimal point. And the last I used is a classification report, provides detailed metrics like precision recall, F1 score, F1 score, sorry, Serbian and English, I don't know what's wrong with me, F1 score for each class. And output is formatted into data frame for better readability. You will see it in the next line. So this is just a function. We call it in the next lines and evaluate our performance. See the results, the confusion matrix, the accuracy, and all the metrics results. And we send their model, X test and Y test. And in every of these methods, confusion matrix, accuracy, and classification reports, we send Y test and Y test predictions because we want to see if we get the same results as it is in Y test. We want for X test to have Y test, and we just see if our Y test prediction is Y test. If it's not accurate. And then we do this for every instance in our data set and globally count all these valid and non-valid variables. That's what goes in Python, what we can't see here. So the first model I chose as logistic regression. Logistic regression is a classification algorithm. I think you all know what is logistic regression, but just to say, it predicts probability of a class by fitting a logistic function to the data. So we just use logistic function. It's simple and it can be used in this problems like classification. It estimates coefficients for each feature during training to maximize the likelihood of correctly predicting the target labels. It's commonly used for binary classification problems. It's the best for binary classification problems, but it can be extended and it can be used for multi-class classification. Here we have just binary classification, so we know that it will be okay. And when we want to use some model in Python for some prediction, we just call it by their name. We imported logistic regression and random forest, etc. in the first import when we imported all the libraries. I can show you if you forgot. So we here imported random forest, AdaBoost, logistic regression, MLP classifier, and because of this, we can use it by their name. So if you can't use something in your code, just import it somewhere and run the code. And here I use logistic regression, and by calling logistic regression, we just create one model, and I put this model into this variable LRCLF. And after we have our variable for the logistic regression model, we have to fit it. The fit method trains the logistic regression model using the training data, xtrain and ytrain. So we send our xtrain data for the x-axis and our ytrain data for our response 0 or 1, and we just train it with a logistic regression model. In xtrain, we have all the columns except response, and epsilon we have just response. That's our target. And what is training doing? It's during training, the model estimates coefficients for each feature to maximize the likelihood of correctly predicting the target labels and learns the relationship between the features and the target variable. So with fits and all this data, every relationship between the features is being learned, and we then can evaluate our model. So first you have to create your model, put it on some variable, then just fit it so our model can learn some relationships with our data, and then we can evaluate and see the results. When I run this, I will now have my logistic regression model and fitted data. They learned something, and now I can see if the logistic regression is good for my problem or if it doesn't. And the next stop is to evaluate it. So we wrote the evaluate function that's here, you know, and when we use it, we have to send our model. You can see our model here, and x-test and ypsilon test. Just send x-test and send ypsilon test. So again, evaluate function is used to assess the performance of the trained logistic regression model. So with evaluate, we get our accuracy, our confusion matrix, and everything. In the evaluate function, first we send LRCLF. That is our trained logistic regression model. So our fitted. We fitted the model, and our trained model is being used here. After, we send x-test. That's our test data for the columns that are not target. All the columns, but not target. And for ypsilon test, we use just our target column, that is response. We send this data to evaluate function, run it, and we got the response. That's the accuracy and everything we need to know. So here we can see confusion matrix. We can see accuracy. we can see metrics results, precision, recall, F1 score, support, and the values here. That's the most popular and commonly used metrics. So you can use this or Google some other and choose different ones, but that's for our case the best metrics. And we can see the results. Here is the confusion matrix. Maybe you have learned it or don't. You can Google it, how a confusion matrix looks like. But here, this number here, 374 is the true negative. Here, 11 is the false positive, as it's their name says, positives that are false. Here we have 52 that is false negative, negatives that are false, and this number here is true positive, and it is 10. That is for confusion matrix. After, we have accuracy. Our accuracy score is 0.8581. That means 85.81% of the predictions are correct. That's a good result because 100 is of course the best, but 85 is okay. And for the classification matrix, we can see precision. We have two classes. We have class 0 when we have situation where the customer did not respond, and we have one that is class where the customer responded. So here we can see that for class 0, 0.877, etc. Labels are correct. So we have accuracy of about 87.71. For the class 1, that is low number of 47.61. So that's for class 1. For the recall, we have high accuracy for class 0, it's 0.97. And for 1, it's about 16%, and that's low number. For F1 score, we have 92%, and for class 1, 24. And for support, that's the numbers here. So what's the point? The model performs well, we can see, but from these numbers, it struggles with positive class. You can see that for positive class, we have low numbers because 100 is of course the best. Everything above 50% is not that good, so it struggles with this positive class, but it is good with 0 class, so with negative class, but the overall accuracy is good, and we can use this model, but maybe try to create something better or try with some different parameters. That's the first model we tried, so we can go to the next model. I have 15 minutes, so I will try to be just to see. Okay, I think we will have time to do everything now, because for the next lesson we have something else. A random forest is the next. Support vector machine is our next model, and as in previous, just to say, support vector machine is a powerful classification algorithm, and it works by finding a hyperplane to best. Sorry, just a second. I have some problem.
We cannot hear anything.
Hello.
Okay, now it works.
Okay, thank you. I was talking with myself because I answered the question, is anyone listening to me? I thought that all you got bored and are not with me anymore, so thank you. I will start my lesson now again. So what I said with myself only and ghosts, the model is support vector machine, our next model. And we just do things like we did in for linear regression. The support vector machine is also one model we can use with classification. And we have some parameters. Here we use kernel. And we can use different types of kernel. Now we chose linear because our data is linearly separable, so we can go with this one, but we have different types, and you can Google it and see all other kinds. And we just called our support vector classifier. We imported it in the first step when we imported all the libraries. For kernel, we used linear because it's effective for our data because it's linearly separable. And when we call this function, we create our model and put it here. So in this variable, we have our support vector classifier. And after, as in previous step, we have to fit it. And here you can see what the fit method does. The fit method trains this SVM model by finding the hyperplane that maximizes the margin between support vector from different classes. Support vectors are the critical data points closest to the hyperplane, which influence its position after executing this code. This object contains the trained SVM model ready for evaluation or prediction. I don't have time to tell you everything about this models, but you can see very good lessons on YouTube maybe, or to just Google everything. Now you have ChatGPT, etc. So you can see all about this models. This is practical implementation, and I have to be fast, so we will just run this code. When I run this, I have my model here, and just a few seconds. It has to fit. But it will eventually do this. I can go next because I already done all these steps. As in previous model, the next step is to evaluate this. So we send our model, we send X test, Y test, and we get the results. Here we also have confusion metrics. We also have accuracy. We also have precision recall, F1 score, supports, everything. We for class 0, we can see bigger numbers, so more accurate, and for class 1 we can see lower numbers. So in this case we can also see that our performance is poor for positive class, especially in terms of recall. So for recall we have just 12.9%. that is low, and that's not good. So solid accuracy, but we can try with maybe different parameters, etc. That's our second model. Our third model is random forest. I just call the random forest classifier imported in the first step in this notebook. Here is the number of estimators, number of trees in the forest. You already know that random forest classifier is learning method used for classification. In this case, because it's classifier, you also have another one for other tasks, and it works by constructing multiple decision trees during training and outputting the mode of the classes of the individual trees. So we have trees, and an estimator is the number of them. So in the forest, we have 100 number of trees. Bootstrap is false. It disables bootstrapping, so each tree is trained on the entire data set instead of a random subset. If you want to train each tree on different parts of data set, you can do something else, but I prefer to train it on the entire data set, each tree. I think it's better, but for every situation you have different better. I say here is better, but maybe somewhere else it's not. And you just have to try and see the results and everything. So as in previous steps, I have to fit it. When I fit it, I can evaluate it and I get all these results. Here I can see it's better on 0 class. For 1, it's poor, but it's for equal better than previous one. And here I have a conclusion that performance on class 1 is weaker and the overall accuracy is high. It is because we have a 0.87, etc. So it's good, but not the best. Then I used AdaBoost classifier. It is a boosting technique and it's very popular now. So you can learn about it more when you have time and you want. Here we have some key parameters. I use random state and estimators. It has more. You can Google it and try. And here's the training process. You will have this notebook and you can just see and read everything I have here. I have a lot of text because I think it's good for you to know and to read everything that's going on here, not to just remember what I told you. So I just love to have all these comments and everything. I hope it will be okay for you. And I just used AdaBoost classifier. That's our model imported, and that's parameters. Random state is 0. So I fixed, as in previous, I had some other random state. I have 42, I guess. Here I just wanted some seeds, random seeds. And for n estimators, maximum number of classifiers, iterations, is 100. And you can try with different numbers and everything. And as in previous steps, we just fit this and after evaluate the model. So here we have the accuracy that is high and very high for 0, 1, and very good, better, not so very good, but better than previous models. You can see we don't have 0.1, 0.2, we have 0.58. That is okay, not the best, but better than previous results. So I can see that's the best model here. So its prediction is lower, of course, but better than previous models. So for our problem, the AdaBoost did its job good. After, we had hyperparameter tuning and grid search CV. That's a process to find the best hyperparameters for a model. Here we chose it manually. We said, I want this, and try with different ones, but we have some kind of grid search and hyperparameter tuning where we can write some code and get the best results. You can write, you can see and read it here, how it works. I just want to show you because we have 5 minutes. Here is for logistic regression. We just defined parameter grid for hyperparameter tuning. So we just said parameters for logistic regression are penalty, it can be this, or none. Class weight can be this or none. solver can be this, etc. So we put here all the parameters that can be used for logistic regression. Then we use some function we previously also imported, and we use this grid search CV to cross-validate our optimal hyperparameters. So we send our model, we send all our parameters, and we want to score by accuracy all of them. And after we did this, we had to fit it and see our best score and our best parameters and print it here. Here in LG optimal parameters, we will get some data. With dot best score, we will get best score. With dot best parameters, we will get best parameters. And after we initialize the logistic regression with the best parameters, so we use our model, and here are all the parameters that are the best that previous code did for us, and we fit our model with this best parameters and then just evaluate and print the results. So we predict and print confusion matrix, accuracy, metric results, and we can see the confusion matrix here, accuracy, and precision. So precision is here, this number, recall, F1 score, etc. So these results are better than the previous when we put it manually and checked it. Here we get from Python and computer and all the models and code some best parameters and just say, okay, I will use them if it's better than my manually written parameters. So you can also read everything here I wrote for you about their performance. We then do this again for random forest. Everything is the same. We just have different parameters for this model, and we just again use grid search CV, send the model, parameters, accuracy, scoring, fit this, wrote best score, best parameters, then initialize our random forest classifier with our best parameters, fit it, and predict and print the results here. And we see all these results and can see if they're better or not. I think they're a little better than when we type all this manually. And here you can just read about our results. AdaBoost is next. I guess it's now done, this block of code from the previous lesson. I don't know what was it. It was maybe random forest. I don't know. So AdaBoost, we here have AdaBoost parameters. We just write it here and do everything again. So grid search CV, send the model, send the parameters. Scoring is accuracy. We want to score it by accuracy. Fit it, write best, print best and best score and parameters. Then initialize AdaBoost classifier with best parameters found by Python and everything. Fit it to our best AdaBoost model, and then predict and get the results here. So print it and you can read everything here. And I have 1 minute, yeah. The last model is support vector machine. We did everything again. So parameters, then we do cross-validation, grid search, then print, get the best model with the best parameters. And then we fit it and we predict it and get the results. And here you can read all these things and all the results. And the last one was neural networks. I guess in the next lecture next week, I will tell you more about all of these models, because today we get a lot of talk for visualization and for outliers and everything. In the next lesson, I will not do this again, all these things. I will tell you more about all these models, so we will have time. Now you can read neural networks, and for neural networks, everything is the same. But before that the same. We just have to initialize some neural network model to scale it, etc. So I think it's best to talk about neural networks in the next lesson. I guess it's that's it for today. If you have any question, you can ask me, but I know that you don't have notebooks and you can run this code or type something. So you can try this and ask me on the next lecture or mail me or something. Yes?
First of all, thank you very much for the great overview. It was very useful.
Thank you.
Since I deal with my thesis also shop order data analysis, so it was very useful. I have a practical question that for me was very challenging to export this some part or full long reports into PDF or something like this. Have you got any idea how can we solve it? I mean, if we have a long analysis, and for example, I would like to show it for my teacher on the user.
You just want to export the code to PDF.
Not the code, the result of the analysis.
Results like all these data.
For example, the diagrams and so on.
I prefer to just all this code go and create some PDF file. That's my type of doing that.
Okay. Finally, I used the default print option of my browser, but I was not really satisfied. But I will try again. Thank you very much.
No problem. I can on next lecture just show you the command in terminal to export all of this into PDF. I will show you how I did this when
Thank you very much.
No problem. Any more question? Oh, my mail, yes, of course. Just, okay. So here's my email. You can contact me and I will send all these materials right now. So I hope you will have it lately and see you next week. Thank you very much. Bye.